Welcome back to our channel. Today in this video I will give an example on regular falsi method. Apply regular falsi method to estimate a positive real root of the equation x cube minus 2x minus 5 is equal to 0. Correct up to 3 decimal places. It means that we have to find out the root of this equation up to 3 decimal places. So first of all, let us denote the given equation with f of x is equal to 0. So let f of x is equal to x cube minus 2x minus 5 is equal to 0. Take it equation number 1. Clearly we are observing that this is an algebraic equation. If a transcendental equation is provided in the given problem, then only we can use this similar procedure. Okay. First of all, we have to investigate the initial approximations for required root by using intermediate value theorem. For that purpose, investigate the functioning values. Now calculate f of 0. So 0 minus 2 zeros is 0 again, minus 5. Anyway, result is negative of 5, which is negative. F of 1. Substitute x is equal to 1 in this one. So 1 minus 2 ones minus 5. So it is nothing but 1 minus 7, which is equal to minus 6 less than 0. Now calculate f of 2. F of 2 means whenever we have x in this equation, blindly replace it by 2. So you will get 2 cube, 8 minus 2 4s are, 2 2s are 4 minus 5. So it is 8 minus 9, again it is minus 1 less than 0. Now find out f of 3 in order. You will get 3 cube, which is 27 minus 2 3s are 6 minus 5. Anyway, it is 27 minus 11, which is equal to 16, which is positive. So by observing these two, f of 2 is negative, f of 3 is positive. So by intermediate value theorem, required root of the equation 1 lies between 2 and 3. Okay. But it is better to find f of 2.5 also. So you will get 2.5 whole cube minus 2 times of 2.5 minus 5 is equal to evaluate this type of numbers, you should use the scientific calculator. See this one. This is the scientific calculator of ES plus model. See 2.5 cube minus 2 times of 2.5 minus 5 is equal to this one. It becomes 5.625. So it is also positive. We are observing that functioning value at 2 is negative, functioning value is 3 is positive, also functioning value at 2.5 is again positive. So from above observations, we conclude that one of the root of given equation 1 must lies between 2 and 2.5. 2 and 2.5. We can take this one as 2 and this is B. Okay. So we get this one by intermediate value theorem. Okay. Here f of A is nothing but f of 2, which is minus 1. Once again you can write here. What is f of B? F of 2.5, which is 5.625. Okay. Now by regular falsi method, The next better approximation is for root is x1 is equal to a into f of b minus b into f of a over f of b minus f of a. This is the algorithm in the regular falsi method to find out the better approximations for required root. Now substitute these all values a, b, f of a, f of b in this formula. A is nothing but 2. What is f of b here? 5.625 minus b value is 2.5. Okay, of what is f of a? See, f of a is minus 1. So here we have to write minus 1, but directly write minus of minus is plus. So you will write here only plus 1 by f of b minus f of a. So 5.625 minus of minus plus 1. So 5.625 plus 1. Now again we can calculate this one by using scientific calculator only. See, directly we can use this symbol. So 2 times of 5.625 plus 2.5 times of 1, close the brackets, write the division now, which is 5.625 plus 1 is equal to, so you will get 2.0754. Please write 4 decimal places only after the point. Don't write these all decimal places showed in Calci. Okay, just write only 4 decimal places. It's enough for every problem. Okay, and one more important thing is the value of x1 should lie between 2 and 2.5 only, because initially we said that required root lies between 2 and 2.5 only. That's why the x1 value should be lies 2 and 2.5. It is important. Now calculate f of x1. Now calculate f of x1. F of x1 is nothing but we have to find out f of 2.0754. How can we find this value? In this given equation, substitute this value. If the result is 0, we are observing that this is the 2.0754 is the required root. With this step, problem is completed. Okay, so 2.0754 whole cube minus 2 times of 2.0754 minus 5. Okay, see this calculation. 2.0754 cube minus 2 times of 2.0745 minus 5 is equal to, you will get again negative, minus 0.2096, which is negative. So f of x1 is negative. X1 does not satisfy given equation. That's why this is not a root. Again we conclude that previously we have functioning value is positive at f of 2.5. Now functioning value at this new point is negative. So required root now lies between between 2.0754 and 2.5. So take this one, this new value is a, and this value is b. Already it is denoted by b, no problem. The formula for x2 is similar formula, a into f of b minus b into f of a over f of b minus f of a. Okay, so substitute the values in this formula, which are nothing but, what is a here? Recent value is 2.0754 into f of b. What is f of b? 5.625. 625 minus B value is already 2.5 bracket open f of a. So, f of a is nothing but this one functioning value at 2.0754 which is minus. So, you should write minus of minus plus directly 0.2096 close the bracket over f of b minus f of a is nothing but 5.625 minus of minus plus 0.2096 because f of a is negative here. Okay. See the calculation here. Again take a division part which is this one 2.0754 bracket open 5.625 close the bracket plus 2.5 times of 0.2096 close the bracket. Denominator is 5.625 plus 0.2096 whose value is 2.0906. Okay. Don't write all decimal places here, just write first 4 decimal places, it's enough. Now calculate f of x2. Now what is f of x2? We have to substitute this new value in the given equation. If it is exactly 0, we can stop the problem with this step, okay, which is 2.0906 whole cube minus 2 times of 2.0906 minus 5. So, do not forget one thing, given equation is f of x is equal to x cube minus 2x square, sorry, minus 2x minus 5 is equal to 0. In this equation, I substitute this value here. Now, calculate this one. 2.0906 whole cube minus 2 times of 2.0906 close the bracket minus 5 is equal to, again it becomes negative which is minus 0.0440 negative. So, this is also does not a root. Okay. So, anyway, now root lies between 2 point this new value 2.0906 and 2.5 because previously we get the functioning value at 2.5 is positive and recently we got the functioning value at this point is negative, that is why. So, again by regular Falsi method the next better approximation is denoted by x3 which is given by a into f of b minus b into f of a over f of b minus f of a. It is better to take every time the new approximation is a and the old approximation is 2.5. So, substitute these values here. Now, what is a value here? A is nothing but 2.0906 of f of b is f of b is 16 already sorry. So, 2.0906 f of b is nothing but 5.625 minus b is nothing but 2.5 and f of a is this functioning value which is negative. So, directly write the negative sign in the outside. So, minus of minus plus 0.0440 over functioning value at b minus functioning value at a. So, 5.625 minus f of a is this one, it is also negative, that is why minus minus plus 0.0440. Now, calculate this one by using again scientific calculator. See. So, take this one 2.0906 bracket open 5.625 close the brackets plus 2.5 times of 0.0440. Write the division. You should close the bracket here, otherwise you will get syntax error, do not forget it. So, in the division we have 5.625 plus 0.0440 is equal to, so it becomes 2.0937. 4 decimal places are enough. Okay, now we have to substitute this value in the given equation again. Therefore, f of x3 is equal to f of 2.0937 is equal to 2.0937 whole cube minus 2 times of 2.0937 minus 5. So, we are observing that again we have to find out this one in scientific calculator, which is 2.0937 cube minus 2 times of 2.0937. Okay, close the bracket, minus 5 is equal to, oh sorry, some bracket is not closing here, see again, 2.0937 whole cube minus 2 times of 2.0937 minus 5 is equal to. So, we are observing that this is minus 9.499 something into 10 to the power of minus 3. Whenever we have a number in product of 10 to the power of minus 3, it is known as scientific notation of a number. It can be written as first digit 9 should be third decimal place after 0. So, it is nothing but 0.009, which is also negative. So, still x3 does not satisfy the given equation. That is why x3 is also not a root for the given equation. So, we have to find out the next better approximation also. So, now root lies between, required root lies between the new value, which is 2.0937 and 2.5, because previously we got the positive functioning value at 2.5 only. So, you can take this is A and this is already it is B. Now, the next better approximation x4 is, you can use a similar formula at every time, A into f of B minus B into f of A by f of B minus f of A. So, I do not want to write every time this formula, it is enough to write for 2 or 3 approximations. It is not necessary to write formula for every approximation. So, A is nothing but 2.0937 into f of B. What is f of B? 5.625 minus B value, which is 2.5. We have to write the recent value, reset functioning value, which is minus, already minus is there. So, minus of minus plus 0.009 over functioning value at B minus functioning value at A. So, 5.625 minus of minus plus 0.009. So, we have to find this value now. See this one, 2.0937 bracket open, 5.625 bracket close, minus, sorry, not minus, it is positive, 2.5 times of 0.0009 bracket close. Do not forget to close the bracket here. Division is, denominator is 5.625 plus 0.009 is equal to. So, it becomes 2.0943. So, now we have to find out f of x4. After getting every approximation, you can substitute that value in the given equation. So, you will get f of 2.0943, which is 2.0943 whole cube minus 2 times of 2.0943 minus 5. See the problem. So, bracket open, 2.0943 cube minus 2 times of 2.0943 close the bracket, minus 5 is equal to. So it becomes minus 2, it is negative, minus 2.806 something into 10 to the power of minus 3. It means that you should write first number 2 in third decimal place of the after the point. So it is nothing but minus 0.0002, which is negative. So it is better to find out another approximation also, because still we did not get the exactly 0. So now required root lies between the new value 2.0943 and 2.5. So you can take this is A and this is B. See this one. The next better approximation is denoted by the x5, because already previous approximation is denoted with x4. So it is nothing but A into A is nothing but 2.0943. It is not necessary to write every time this formula. Okay. A into f of b. F of b is nothing but 5.625. Already we have here, minus b value is 2.5 and recent negative value is this one. So minus of minus plus 0.0002 over 5.625 minus of minus plus 0.002. Again we have to calculate this one. See, open the bracket. Now take the this one 2.0943 bracket open, 5.625 close the bracket, plus 2.5 times of 0. Actually it is negative, minus of minus becomes positive here. So 0.002 close the brackets and write the denominator, 5.625 plus 0.002 is equal to. So it is 2.094. We are observing that, you have one more thing. We are observing that in x4 you are getting 2.0943, in x5 we are getting that 2.094. So continuously 3 decimal places are same. That's why we can stop the problem with here. Clearly x4, the fourth approximation is approximately equal to fifth one. So we can take the required root as the required root of given equation 1 as 2.0994. Okay, we asked that we have to find out the root corrected to 3 decimal places only. That's why we stop the problem here. Okay, don't forget to write in the bracket approximately, because this is not exact root, we are estimating a root only. Okay, this is the regular falsi method. I hope you are all understand this problem. In the next session I will give another problem. Thank you.